I'm Jose Carlos. I worked in this area of composites for a while, around 12 years. I've worked at Barracuda, working at engineering, importing several other departments. And now I have my own company for a couple of months. And today I would like to talk to you about carbon fiber and performance vessels that has increased a great deal in Brazil. So, when we think about carbon fiber, there are some things that come to our minds: resistance, weight, strength. Imagine if we had a competition or canoeing competition where the athlete had to row as a C1 canoe with 10 more kilos. Imagine if the competition sailboat as a 49 fish of Cayena and Martina. Can you imagine if you had a higher weight, how that would impact in how to maneuver the boat? What would be the speed? And when we talk about high performance, like this America's Cup or Volvo Ocean Race, to me, they are the top of the summit of naval engineering. You have ships, sail ships that goes over. They sail over the speed of the wind, 42 knots, at a 35 knot wind. So the structural efficiency is very high. There are several factors that are going to take that to the performance, and the material that is used is for sure one of these factors. It may seem to be outside our reality, but it's not. Today in Guarujá, we have performance boats that uh, reach more than 200 kilometers an hour. Why do we use carbon fiber in this type of vessel? When we think about carbon fiber, the mechanical characteristics and also the low weight are the main factors that we have to consider. But how low that weight is or how high these mechanical characteristics are, that's what I had to bring to you so that we could talk about it. Talking about the density, here I have tons per cubic meter. Just for us to understand, the two first materials are two fiber, glass fiber laminate with epoxy, 800 grams per square meter, 1808 oriented to 45 degrees, and a laminate of a single directional material, 600 grams. They are the other two as unidirect single directional, biaxial, 400 grams of carbon is HS, high strength carbon, that we find in the market in a more useful way. Then we have uh, single carbon, just for us to have an idea, because the high modulus is very difficult for us to have here. There are several regulations that prevent the export of that kind of material, and some other materials that are used in boats and in ships. One steel alloy, two aluminum alloys, and naval compensado, uh, laminated. So these fibers is laminated. They will be below the 2 tons per cubic meter of density, particularly carbon fiber, and aluminums will be 2.8 and steel around 7.8 tons per cubic meter. We go to the elasticity mode. We have traction, compression, shearing, for stress, fatigue. I would need three time slots, and we would end around 4 p.m. The elasticity mode, the traction, even the glass fibers have a reasonable modulus. When it's carbon fibers, single directional, These moduluses are high, very high compared to aluminum. They're higher and very relevant compared to naval carbon steel in 31 ASTM 131. It's a classified naval steel. So large vessels use that kind of material. So we see that the carbon fibers have a very high performance and they lose for steel. Then you have traction resistance. We have carbon fiber, the standards that are usual that we find have this resistance over steel. It's so relevant for us to consider only the the existence by strength, because if we think about only strength, uh, aluminum and steel has good strength compared to glass fiber, but that's not what we see usually in the smaller boats, 50, 60, 80 feet under. We see that a lot of glass fiber, carbon fiber is used, and that happens because of the specific resistance. So it's the relationship that we have between the strength and the density of this type of material. Uh, when we take all those values and divide by the density of the material, we see that all that relationship that we had, that this steel was way above the others, it starts being under carbon fiber. So you see it better when we have one chart next to the other. So in blue, dark blue, that's elasticity module alone for each material. In a light blue, the specific modulus. In steel, it had a very high amount. And when we compare this amount to the density of the material, we see that it drops a great deal. That's why this material is so used in these vessels that require more speed and strength. The same thing will happen with the tensile strength, the strength on its own, specific strength. When we divide carbon fiber that had a very high strength with very low density, 1.6, 1.56, it will have more advantages on the materials. But there is an interesting point. When we divide it by the density, even the glass fibers have advantage compared to the metals, particularly the aluminum. And when we put one chart over the other, it's clearer. But it's not only about the material that we have to take into consideration. Of course, it's this construction process. There are several other factors that we will consider, and the construction process is one of these factors. We know that each process has a relationship between resin and fiber that is inherent to that process. We have a spray app, manual, and that have quantity of fiber that reach 40% maximum. We have a fusion vacuum bag where you're going to have 55, 60% of fiber in the laminate. And we have more advanced as pre-preg and autoclaving, curing, where you put more temperature, more pressure, remove resin, and get more resistance. These two processes are more advanced. So for ships, apart from America's Cup, that are very high in technology, they're technologies that are complicated for us to put in big vessels, 80 feet intermariner, 24 meters azimuth, and placing it at an oven that has controlled temperature. So we're going to be in the vacuum bagging, and also vacuum infusion. Just an explanation, the content of fiber, I'm talking about the quantity of fiber over resin in the laminate. And once again, we want to be in the middle, the infusion and the vacuum bagging. And why is that important? Because when we look at the elasticity modulus, the more we increase the content of fiber, the more strength you have. So when we are at 60% with infusion, we have a modulus around 90 gigapascal. Whether if we had a manual one around 40%, we would be around 40 and 50 gigapascal. Even using a very strong material, if we don't have a compatible construction process, we won't be uh, we won't be able to extract all the performance from the material, and also the tensile strength to be around 590. If we had a manual laminate, we would be less than 300. So now to show you this process in the vessel that I said is produced in Brazil. This is in the US, Statement Marine by the TMG in Guarujá. They're making these vessels, racing vessels. The putting together the laminate by infusion, very dry. It's very important for the assembly to be very careful. We don't want to have empty spaces between the space because it's going to create voids, and then we will have a structural or weight problem. Um, all this material has to be put together carefully for the infusion to happen efficiently. This last layer is a 400 grams by axial. This is a hybrid laminate. We have a mix between biaxial and single directional between the layers. One more picture. There is one more picture from this part of the boat. You can see the foams. You can see that the laminate is very well compacted. It's very well put, assembled. This is very important for this type of application. And this is a vacuum assembly. We decided to do a sequential assembly, longitudinal and transversal, because there is a lot of screen. There are sandwich and solid laminates. So we would have different laminates, types of laminates. If we didn't use lots of fabric, we couldn't do the infusion correctly. Now the vacuum applied, we can see that the pressure is big, and the infusion of the vessel, that was very easy, even 40 feet. We had around 20 minutes, so it was very easy. We see by the lines that it's very homogeneous. There are no leaps or places where the front of resins are faster than the others. With that, we can see that the core is well touching well. Otherwise, there's some shots at different points, and there is this infusion without any issues. And we see that nobody needs to go up the mold to do any type of fixing. Of course, in infusion, sometimes the bag is closed in our control. Fala com ele o que ele quer. We want to infuse very quickly the material. This is an infusion that was a gel time around 15 minutes. We have to control with some breaks these glass fiber layers to reduce permeability so that we don't pull a lot of resin to the trap, and then we have to feed with resin all the time. We can break this infusion as soon as it reaches 100%, and that's efficient, and there is an end result that is very good. So this is the first vessel. It was made there. It's going to be in the water in the next day. It is painted. That's for the US market. They really like this race boat paint. And then there is a light laminate compared to the first boat that was done. You reduce most of the weight. Today you have the cockpit and the hull. You have 1.6 ton against the 1.2 tons. So it's very resistant, very strong, and very lightweight, which will be very fast for the end user. That's what I wanted to bring to you. These are my contacts if you would like to say anything, and I'm going to throw the floor open to questions. Hello. About the glass fiber material to decrease the probability of getting to the track. Do you use a briefer? Do you use a sheet? Usually we use fabric, could be a mat, but because the hulls have a curvature, there is some leftover fabric. So we use the leftovers to do this bit on the side or in the center, depending on the type of infusion. But the permeability of glass and carbon is very low, pure, because when we do a sandwich, the foam needs to have grooves, or when it's solid, we have to use an infusion screen to increase the permeability of the laminate. The pure laminate, only the glass fiber will stop that because there is low permeability. Any other question? When you put a lot of screens together, how do you put them together? Are they sewn? Are they... Okay, no.
Acho que fabric or materials, tela,
What did I say? Okay.
screens.
The adhesive, contact adhesive, usually Super 773M. It's an inert adhesive for this type of resin. And for sure, you should use the least as possible, only enough to keep it in place. When we place too much glue, we can create points where the resin will not penetrate. So, and sometimes it reacts with the resin so that it won't dry. It even wets the laminate, but the entire hull is dry, and there is one point of 10 centimeters where the resin is wet. So sometimes that's the influence of the glue. It's the least possible. I like to use the glues in a can. You, it's very easier to use the can rather than the spraying can. So these are the most recommended ones. We can use some nylon clips to keep these fabrics in position. It's an inert material. You don't need glue. It's more complicated to find that. It's hard to find it, and I was never able to find it. Epoxy resin, polyester or vinyl ester. It was vinyl ester in this case. We chose this boat. The hull was vinyl ester, but the deck was epoxy. The they want to use only epoxy, the marine. We are testing because it's a bit different. You don't have control in gel time, any polyester ester vinyl, because you put more or less catalyst. You have to have a hardener that is specific to be faster or slower. It's hard to have qualified labor for epoxy. In Brazil, we have to train people so that we can make all pieces in epoxies. I've worked for 20 years with Geronimo doing windmills by infusion, the blades, windmill blades. I work with Super 77, and I thought that each pass you decrease 10% the mechanical properties. Now, in Argentina, they're doing a lot of vessels in infusion. The recommendation is not to use that because it affects the cure of the products. So that's for everyone to pay attention because many vessels were manufactured by infusion and they didn't know why it didn't get hardened. So be careful. We can use this stock because it's a source, an important source of mechanical failure. So study that. It's our recommendation.
Perfect. That's a very good question, and your comment is really welcome. In practice, we often see this happen. If you overdo the glue, for example, then you lose mechanical characteristics, you lose the cure. Even the infusion uh, is reduced because it seals up the spaces. It's one of the most important points to pay attention to in this kind of infusion, to use as little as possible of the material. Actually, better not to use it at all. In fact, what you can do is cook. You can, if you sew the materials together, the fabrics, yes, we're using it only vertically. We don't use any type of glue horizontally. Even sewing is hard. It's problematical because of the time. You add a great deal of time to the process if you sew. So we can use glue with great care, and many types of glues are, with interesting characteristics and properties, are being developed. They don't interfere in the quality of the laminate. I'm sorry for so many questions. Sometimes we've had to throw away complete hulls. Really be careful. We had to scrap. So, for example, transversal traction or tensile tests. I agree. Absolutely, you have to test all kinds of laminates. You want to be absolutely sure that the material being used is going to perform. Any other questions? How are you doing? And about using epoxy resin in these hulls, do you think that will reduce the weight of the vessel? No, not the weight. The density, the resins are very similar in their densities. We don't have such a major difference between, for example, the density of an epoxy versus a vinyl ester for the overall weight. What we do know is that it will last longer if there's a greater adherence between layers. In terms of weight, though, I don't think that there's a significant difference. The density is so similar, that's what it is. In the example that you gave us, so you carried out infusion of the deck and the hull. how did you actually join one to the other? And structurally and aesthetically, did it work together? Yeah, it's this vessel is one with a very great deal of paintwork, so we can carry out this gluing. It's laminated at the edges, and all of the struts and the lengthwise. What you actually have is divisions. It's methacrylate, and the rim is laminated with a couple of layers of carbon.